All right, so welcome everybody. We'll get started here in a second. And remember, we are talking about counting stuff.
Hey, Dr. D.
Hey, what's up?
Do we have to type here in the chat?
You have to type something.
Oh shit, cause like past few classes I didn't do that, but I was in class though, so my fault.
Well, just remember to do it the rest of the time.
All right.
Yeah, so it's may not end up mattering for you, but if so, we can talk about that when it comes up. Obviously, grading here toward the end of the semester is going to be a little different, but I'm trying to make sure that it is as fair and balanced, we'll say, as possible.
Oh, we most definitely gonna talk about that, man. All right, God.
All right. So should be enough time for everybody. Okay.
Hey, Dr. D. I came in like on the end of what you were saying. Can you please repeat that?
About what?
I didn't hear what you were talking about.
Oh, I was just saying that please remember to sign in to chat. You just have to type something here, preferably not a an expletive or a overly colorful word. But yeah, just something so I have a written documentation of because it doesn't save the attendance logs. I have to buy the fancy version, the expensive version. So that's the way we have a dedicated attendance record. So, and again, with attendance, it's not something that I want to hold against anyone. I understand stuff happens, so I'm not looking to trip anybody up. So, I'm not gonna come after your family or anything. But it is important to have as much documentation as possible. Otherwise, if the chat log says you weren't here and there's no proof on the video, I can't, without a shadow of doubt, prove that you were or were not somewhere. So it's just about keeping our bases covered. So yes, please make sure to sign into the chat. All right, let's get started. So we've been talking about counting stuff, and we were going over this list of stuff that we're trying to see what kinds of things can be easily counted, and what just kind of aren't, without going through all of the different possibilities. And even then, the possibilities are not very clear cut. So we have something like the number of 3-letter words that can be formed using the letters M-A-T-H. Well, that's pretty easy. There are 3 possible slots that the letters can go. and there are 4 different letters that we can use. So the number of words is just 4 times 4 times 4, which is 64. But in number B, there's not really a whole lot of ways we can easily count the number of ways you can change a $1 bill with 5 nickels, 12 dimes, 6 quarters. There's a bunch of different, possibilities and rules, and there's just no way to easily count that without just listing out all the possibilities. The number of ways that the number of different 5-card hands that you can draw from a deck of cards, we said was very simple to calculate, even though it's a really big number. For the first slot, you'd have 52 options because there's 52 cards in a deck. For the next card, you have 51 options because you have to take that one you already used out of the deck. And so you just multiply 52 times 51 times 50 times 49 times 48. Pretty straightforward, even though it is a big number. That's where we left off. So what about the number of different 5 numeral combinations for a lot? And numeral just means digit. So how many 5-digit combinations can you have for a typical combination lock? Well, how many spots are there?
5, right?
Yep. So you have 5 different spots. And how many options are there for each spot?
5, right? Is it 5?
So it's a combination.
Oh, 10?
10, yeah. So each spot can be 0 through 9. So it's 10, 10, 10 times 10. And so what is 10 times 10 times 10 times 10 times 10? Or 5 tens multiplied together. How many zeros is the
100,000.
Yeah, 100,000. So remember, with tens, you just add a 0 for every 10 that you're multiplying. So that becomes a 1 with 5 zeros, because there are 5 tens. Okay. How about the number of license plates in Florida? So in general, plates have 3 numbers and 3 letters. So is that something that we can easily count, given the ways that we've been talking about?
Yeah, so it's gonna be like 6 slots like all together.
I'm sorry?
It's gonna be like 6 slots all together.
Yeah, so it's going to be, we'll do this one on the board. So this was the last one, the combination lock, 5 different slots, and each slot has 10 possibilities. So with this one, you're right, there are 6 slots. So it's supposed to be an orange. Just go with it. Okay. So how many possibilities do we have for each slot?
Say that again.
How many possibilities do we have for each slot? We can start with the first slot.
5, right?
26.
Oh, my bad. I messed that
Go
up.
ahead.
No, go ahead. Go ahead.
Would it be 26, right? For one of the letters, I'm assuming.
So if you're talking about the letters, yeah. So this has this plate will have 3 numbers and 3 letters. So we can do the letters first. It's fine. So one slot is going to be 26. What about the next slot?
25. Or 26 though.
Yeah, 26 still. And why 26, not 25?
Because it didn't say you can't use repeats.
Exactly right. Yeah, there's nothing that says that you can't repeat numbers. So that's a very important thing to look for, is whenever you are in a situation that somehow exhausts one of the possibilities, like in taking cards out of a deck. Well, once you take the 2 of hearts out, the next one can't be that because there's only one of them. So in a case that you're going to use up those possibilities, that's when it drops off. But there's no reason that says that we can't type out, you know, AAA as a value. So we have 26, 26. And what about the third one?
26.
26. All right, what about these 3?
Would it be 26 all the way now?
It's not 26 all the way across. So
Would it
the,
be 10?
I'm sorry?
So would it be 10 since we already did 3 letters?
Yeah, it would be 10 because we've already done 3 letters. So now we have to use numbers. So 10, and we can continue that 10, 10. So at this point, we can put it into a calculator and we get 17,576,000 different plates. Again, so these counting type problems are easy to put into a calculator because for the most part, you're just multiplying stuff. The difficult part is the setup. So I write this number for completeness because it is part of the answer, but it's the last little easy part at the end, not the part that requires thought. So just keep that in mind doing these. The setup is where the difficulty is. All right. So let's look at an example. So suppose that South Carolina needs to have 10 million unique cars registered with license plates. If every license plate consists of 3 letters followed by 3 numbers, can they license every car? So we kind of already did this problem just a second ago, because this is how many license plates we could have with 3 letters and 3 numbers, right? So part of the thing that we were supposed to see was actually in this previous one, what is the difference between this question, E, and the example that we're talking about down here? So what's the difference in the question?
We already know it's 6 plates, and we already know the number that 6 plates give us. So will we divide that by 10 million? Or 10 million divided by the number of plates?
Well, it's not divided by 10 million. It's, you can make, so can you all see my screen right now, or what do you guys see?
We see the problem.
You see what?
The problem, like, you get what I'm saying?
Like on my video feed, what?
Yeah, basically, like, we see the question.
Okay, all right. So this is what we had for that last one. Technically, it was wrong because the question said Florida license plates have 3 numbers followed by 3 letters. So technically, I didn't stop us. It's 3 numbers, 10, 10, 10, 26, 26, 26. Okay? So you can have that many different plates. So what does the South Carolina one show? What is the South Carolina question? See, it says that we have 3 letters followed by 3 numbers. So this question is three letters, 26, 26, 26, 10, 10, 10. So that's the question. But what's the difference between this and this?
The state,
I'm sorry?
like the state.
The state. But does the fact that Florida has numbers and then letters change anything about the number of plates that South Carolina could make with letters followed by numbers? It's kind of a trick question, but so essentially what we're asking is there any difference between 10 times 10 times 10 times 26 times 26 times 26 and 26 times 26 times 26 times 10 times 10 times 10?
No.
No.
It's ordered differently.
Yeah, because we're multiplying all of these possibilities out, it doesn't matter. So still equals 17,576,000 plates. So the question about can they all be licensed or registered? The answer is yes, because 17 million is bigger than 10 million. So we can license or register everyone because there are enough possibilities. And we would have, 7.5 million leftover license plates if we made all of them. So kind of where you guys were going a second ago when we did the Florida problem. So suppose we again have 3 letters followed by 3 numbers, but this time you cannot have repeated letters or numbers. Then how many license plates can we have? Well, let's count them. How many spots are there? How many slots are there?
6.
Yeah, so there are 6 total slots. And how many possibilities are there for the first slot?
26.
26. Exactly right. Okay. How about for the second slot?
$25.
Why 25?
You can't have repeated numbers.
Because you can't have repeats. Exactly. So, what about the next slot?
24.
24. All right, very good. What about the other side?
10.
10. Why 10?
Cause you get up to 10 numbers. It's up to 10 numbers in the
Yep, there are 10 different digits. Exactly. What about the next slot?
9.
9. And then
8.
8. All right, very good. So because we are losing possibilities every time, we have to account for that. So we put in 1 minus every time. Well, you plug this in to calculator, and what do you get? Anybody got this one?
Will it be 11,232,000?
That's what I got. Very good. We have a guest star out there somewhere. I heard what sounded like a very young voice.
Oh yeah.
Hi.
Say hi.
I'm finna cry. That sounds so cute. Who is that?
Right.
Say hi.
I'm
Say
about
hi.
to cry.
He waving his hand.
Well, hopefully we'll learn something today. Just painting on the board. Awesome. Okay, yeah. So very good. 11,232,000. So can we still license everybody?
Yes.
Yeah, because we only need 10 million. Exactly right. Okay. Very good. So this is the kind of thing we're looking out for, is what happens when you have possibilities that get used up. What happens when it doesn't matter? You have all the numbers or all the letters. So this kind of brings us back to one of the things that we worked on the very first week was how many different ways can you arrange, or not, it's probably like the second week, when we were talking about birth orders and that kind of thing. Very, very much related to this idea of counting. Counting all the different ways that you can have so many different outcomes. So kind of coming back full circle here. So let's try another example. Suppose you flip a coin 3 times and keep record of the result. In how many ways can you obtain at least 1 heads? Okay. So, kind of a weird question. Let's think about it for a sec. Suppose you flip a coin 3 times and keep a record of the result. How many ways can you obtain at least 1 heads? Okay. Well, let's start with a different question. Okay. Because this, on its face, is kind of difficult to think about. So let's start with a slightly simpler question, or break it up into 2 different questions. Let's keep the first sentence. Suppose you flip a coin 3 times and record the results. How many different possibilities can you obtain, do you get by flipping a coin 3 times? So how many spots are there?
3.
Okay. How many options for these slots?
Maybe 2.
Yeah. 2 for the first one. What about second and third ones? Don't overthink it. Don't second guess yourself.
Maybe 2
So,
again.
is it 2 again? Yeah. Yeah, because we're not taking out anything at this point. We're not doing anything crazy. We're saying, how many options do we have when we flip a coin? Okay. So, first question, how many different possibilities could we have? Well, what is
8?
Yeah. Right. So we have 8 total different all right. Okay, now let's ask another question. Suppose you flip a coin 3 times, or you have 3 coin flips. How many ways can you produce something that does not have any heads in it? So, how many options? It's the same kind of question. We have 3 things. How many options do we have for the first one?
2. No, 3.
Not 2 or 3. So it needs to not be heads.
You only got 1.
You've only got 1, and it sounds silly. So again, some of these kind of sound like trick questions. They're not intended to be. They're actually intended to be almost annoyingly, stupidly obvious, and that's okay, because that's how math kind of works to a certain extent. Is you take a bunch of you can break any process down into a bunch of tiny statements to get from anywhere to anywhere else in math. The problem is what people consider to be obvious is different. Some math professors get really bad about, oh yeah, it's obvious how you go from here to here. And everyone in the class is like, no, it's not. So they just ignore the 15 sub-steps they did between there because it's obvious to them. But yeah, so it can't be heads. So the only option is it's tails. Okay, what about for the second coin? Or the second flip?
One again.
One again. And the third flip?
One.
One. Equals number possible with no heads. Okay, but what is 1 times 1 times 1?
One.
What?
One.
1. So, flipping a coin 3 times, you have 8 different possibilities. But if you flip a coin 3 times, the only way, there's only one way it could turn out to have no heads. And that's if they're all tails. So how many possible ways are there to flip a coin 3 times and have at least 1 heads? Not just 1, but at least 1.
7?
7. Why 7?
Because you subtract 1, like to take out for the tail, I'm assuming. You get what I'm trying to say?
Yeah, it's as simple as that. You take out the one, you take out of all of the possibilities, you take all of the ones out that don't fit your qualification, and whatever's left have to fit your qualification. So it's the number total minus the number with no heads. So yeah, and this is a good example of a type of problem that is kind of deceptively, it looks easy just because we're not talking about a lot of cases. You could just write them all out and you'd be fine. But the thought process behind it is actually very important. So it's not easy to count using our methods the number of cases that have at least 1 heads. Like, it's not easy to directly count that, right? A good example of this is you could not write any 3 numbers here multiplied together that gets to 7, right? Like there's no way, because 7 is prime, so there's no way to directly count that. So what we do, it's a neat little trick that's very helpful, is we can easily count the number of all possible outcomes, and we can easily count all of the possible outcomes that don't fit our needs. And the difference, because there's only 2 options, is either this specific thing does fit our needs or it doesn't. It's the only 2 options. You can't have some third option where it kind of does and kind of doesn't. It's not how this works. So because everything either does work or doesn't work, you know that if you subtract the ones that don't work out from the ones that do, or I'm sorry, the number of ones that don't work out from the total pool, the only ones left have to all work. And it's this thought process that's very that's to me where the math really is not 8 minus 1 equals 7. I hope most of y'all could do that without a calculator, but I understand sometimes I use a calculator for mundane stuff like that. But the idea is trying to figure out a way to get what we want, because we can't always just write these out. There's only 8 possibilities. We can just write them out and be done with it. So the idea we're trying to get across is, how do we use the tools that we have to get what we want? So this is what we're looking at, and we're going to finish up the section. We're going to do, this leads us directly into probability, and it's what we're going to kind of be closing out with on Friday. So yeah, so I had some questions about, am I still posting this stuff online? Yeah, this stuff is all on YouTube, and everything, all of these notes are getting posted onto your Genzabar as well. So, and this includes the completed versions, so please feel free to check those out.
When is our test, Dr. Dean?
So our next test is going to open Friday through next weekend.